If you've ever wired a motor starter with a start button, a stop button, and a seal in contact, you already understand 80% of ladder logic. You just haven't seen it drawn this way yet. Let's fix that. Before PLCs existed, plants ran on relay panels, real electromechanical relays, wired point to point. An electrician designing that panel would draw the circuit on paper, 2 vertical power rails, and horizontal lines connecting them, each one a control circuit. Because it looked like the rails and rungs of a ladder, the name stuck. When PLCs came along in the 1970s, engineers didn't want to retrain every electrician on a new symbol language. So the PLC manufacturers kept the ladder drawing style, same rails, same rungs, but now it's software instead of copper wire. That's why, even 40 years later, this is still the most common language on the plant floor. Every rung works the same basic way. Think of it as power flowing from the left rail to the right rail. If the path is complete, if every condition on that rung is satisfied, power reaches the coil on the right, and the coil energizes. If any condition breaks that path, power stops, and the coil stays off. That's the entire logic of ladder programming: complete the path, energize the output. Everything else we'll cover in this series is just different ways of building and breaking that path. You'll see 2 symbols constantly. First, the contact, drawn as 2 vertical bars, like this. It represents a condition: is a switch closed? Is a sensor active? Is a permit satisfied? A contact doesn't consume power itself, it only allows or blocks the path. Second, the coil, drawn as a circle, or sometimes a rounded bracket depending on the software. It represents an output: turn on a light, start a motor, open a valve. In real wiring, this is the thing actually being controlled. Here's the simplest possible program: a push-button contact, feeding a lamp coil. Press the button, the contact closes, power flows, the lamp energizes. Let go, the contact opens, power stops, the lamp turns off. That's rung number 1 of nearly every ladder program you'll ever see. Now scale this idea up. On a real plant, say, a kiln ID fan, you don't just have one push button. You have dozens of conditions that all need to be true before that fan is allowed to start. No trip active, lubrication pressure good, damper in position, upstream equipment running. Every one of those conditions is just another contact, in series or in parallel, on the way to one coil, fan start permitted. Once you can read a single rung, you can read the entire permissive chain for a piece of critical equipment, because it's built from the exact same building blocks. Let's recap. Ladder logic gets its name from the 2 side rails and the horizontal rungs between them, a direct carryover from relay panel drawings. Power conceptually flows left to right. A contact represents a condition. A coil represents an output. And when a rung's conditions are satisfied, the coil energizes. That's it. That's the foundation everything else in this series builds on. In the next video, we'll take these exact building blocks, contacts and coils, and use them to build a real motor start-stop circuit with a seal in contact, the same logic running on motors in plants right now. If you found this useful, subscribe so you don't miss it, and drop a comment if you've got a ladder logic question from your own plant. I read every one.